Welcome to the deep dive. We're diving into the world of magnetism today. We've got a lot to cover, from ancient lodestones to quantum mechanics.
It's a pretty long story, really, spanning millennia. From the simplest observations of magnets to the technologies that define the modern world, magnetism has always been there, quietly shaping how we see the universe.
I'm excited, ready to have my mind blown. Let's start with those ancient observations. Where does our story even begin?
We got to go back to the ancient Greeks. Around 600 BC, imagine you're Thales of Miletus and you find this rock and it attracts iron.
That's a lodestone, right?
Exactly. It was humanity's very first encounter with magnetism.
Like finding a magic trick just out in the world. It must have seemed like pure magic to people back then. So how did they react?
You have to think about it. This was way before electricity. No one understood these invisible forces. But the cool part is that people saw the potential pretty quickly. Just a few centuries later, the Chinese were already using lodestones to navigate.
Really? So they had compasses back then?
Not quite like the ones we have today. But they were on the right track. They realized lodestones always point a certain way. And by the 11th century, Chinese navigators were using them to sail the open seas.
That's wild. It's amazing how fast they went from, what is this strange rock, to let's sail the world.
It just shows you the power of observation and human ingenuity. But wait, there's more to the story. In the 9th century, Al-Kindi, an Arab scholar, he dug deeper into lodestones. And then in 1269, Petrus Peregrinus de Mercor, he made a key discovery. He figured out that lodestones have poles, just like the Earth.
Oh, so that's where the whole North Pole, South Pole thing comes from.
Exactly. Huge leap forward in figuring out how magnets work. Now, fast forward to the 1600s, and we meet William Gilbert, a true pioneer in the study of magnetism. He wrote this book, De Magnete, and proposed something pretty revolutionary.
Oh, this sounds good. What did he propose?
He said the Earth itself is a giant magnet, and this explained why compasses always point north. Plus, it opened up this whole new way of thinking about magnetism. Suddenly, it wasn't just about these odd rocks. It was about a fundamental force shaping our planet.
That's a huge aha moment. So, did Gilbert's idea get everyone fired up about magnetism?
It certainly sparked a lot of interest. Even astronomers like Johannes Kepler started thinking about it in the 1620s, thinking about how magnetic forces might influence the planets and stuff.
Whoa, so they were thinking about magnetism in space already.
It was a time of amazing scientific discovery, and magnetism was right at the forefront. People were starting to realize that this force was way more powerful and way more widespread than they had ever imagined. But it wasn't until the 19th century that things really took off. That's when the era of electromagnetism began.
Now we're talking. This is where things get electrifying. What happened in the 19th century to change everything?
Well, in 1820, a scientist named Hans Christian Ørsted, he made a game-changing discovery. He found a direct link between electricity and magnetism.
So this basically changed everything, right? Tell me more about how everyone reacted to this connection between electricity and magnetism.
Oh, it was huge, like a scientific earthquake. Everyone thought electricity and magnetism were separate, but Ørsted showed they were, intertwined.
It's like finding out two of your friends have been secretly dating changes everything you thought you knew about them.
Yeah, exactly. And a ton of discoveries came right after. In 1821, Michael Faraday built the first electric motor. He harnessed that connection and made it create motion. Then in 1827, André-Marie Ampère, he made this mathematical law, to describe how electric currents and magnetic fields work together.
Hold on, I need to catch up. It seems like every other year another breakthrough is happening.
Oh, it gets better. 1831, Faraday makes another big discovery, electromagnetic induction. This is the idea behind transformers and generators, the things we need to make and move electricity.
So basically, every time we turn on a light, we should think Faraday.
Pretty much. But the real grand finale of the whole thing came in 1864 with James Clerk Maxwell. He came up with these equations that unified electricity, magnetism, and light, all into a single force, electromagnetism.
Maxwell's equations, they sound legendary. What made them so groundbreaking?
Imagine a rule book for how light and matter work together, how they talk to each other. That's what Maxwell's equations did for electromagnetism. And get this, they were so accurate that they actually predicted stuff about magnets no one had even seen yet.
That's crazy. So we've gone from the ancient Greeks looking at lodestones to a unified theory of electromagnetism. It feels like the peak of our understanding of magnets.
You might think so, but hold on tight, because the story takes another turn in the 20th century. That's when quantum mechanics comes into play.
Here we go. Now things are going to get really mind-blowing, huh? Entering the quantum realm. You ready for this?
Oh, this is where things get really interesting. Remember Einstein? Well, his explanation of the photoelectric effect in 1905, that wasn't just about light. It laid the foundation for quantum theory, which totally changed how we thought about electromagnetism.
Okay, I'm listening. How did quantum theory change things?
So one of the big things that came out of it was the Stern-Gerlach experiment in 1922. That experiment showed that the way electrons spin is, well, it's not smooth. It jumps between specific values, which was a big deal for understanding how magnets work at, like, the atomic level.
Wait, electrons spin? What does that even mean?
Imagine an electron like a tiny spinning top. That spin makes a tiny magnetic field. What the Stern-Gerlach experiment showed is that the spin isn't just random. It's quantized. It means it can only have certain values.
Whoa, that's weird. It's like the electrons doing these specific dance moves, not just freestyling.
Uh-huh. Yeah, that's a great way to put it. And this discovery led to this thing called quantum electrodynamics, or QED, in the 1930s. Basically, it's like the rule book for how light and matter interact at the quantum level.
QED. Sounds intense. Did it, like, have any real-world impacts?
Oh yeah, for sure. It helped us understand all sorts of magnetic stuff, from how atoms and molecules act to, like, the properties of materials. Like Louis Néel in 1947, he used these quantum principles to explain ferromagnetic domains. That helped us understand why things like iron are strongly magnetic.
So we can finally explain why magnets stick to our fridges thanks to quantum mechanics.
Uh-huh, you could say that. But a really big change came in 1988 with the discovery of giant magnetoresistance, GMR for short. Now, imagine tiny magnetic whirlpools. That's basically what skyrmions are. And scientists think they could be the key to building even more powerful computers.
GMR skyrmions. This is starting to sound like a sci-fi movie.
Welcome to the future of magnetism. But it's not just abstract concepts. GMR led to those smaller, faster, more efficient hard drives that we have now. It revolutionized data storage, made the digital world possible. And then in the 1990s, we had this new field called spintronics. It uses electron spin to process and store information. That could lead to even faster, more energy-efficient computers down the line.
Wow. From quantum theory to the devices we use every day, it seems like magnetism has been driving all sorts of innovations. What about now? Is magnetism still pushing those boundaries?
Oh, absolutely. The 21st century has seen some truly amazing breakthroughs, from new materials to new uses for magnetism.
Okay, I'm ready for more mind-blowing discoveries. What's happening in the world of magnetism now?
One of the really exciting areas is memory technology. Back in 2001, Stuart Parkin, he did some pioneering work on magnetic random access memory.
MRAM.
MRAM.
Okay.
So imagine, like, your phone turning on instantly and never forgetting anything you saved.
Wow.
That's the potential of MRAM, all thanks to, understanding magnetism.
That would be revolutionary. No more waiting for things to load, no more losing photos or anything. What else is coming?
Well, in 2017, Pablo Herrero and his team, they found something amazing: intrinsic ferromagnetism in 2D materials.
2D materials.
Like chromium triiodide. These materials, they're just a few atoms thick.
Wow.
But they have strong magnetic properties.
Okay. My brain is trying to picture this. What does that even mean for technology?
What could mean super thin and flexible magnetic devices.
Oh,
like foldable smartphones with huge storage. Or sensors that can detect the tiniest changes in magnetic fields.
It's like science fiction is becoming real. But it's not all gadgets and stuff, right? What about the big mysteries, the things we still don't get about magnetism?
Yeah, you're right. There's still so much we don't know. Like, one of the big ones is the origin of magnetism itself. I mean, we know how magnets work, practically. But what's the fundamental thing that causes this force? How do electrons, know to align their spins and create a magnetic field? These are the questions physicists are still trying to figure out.
That's so interesting. It's hard to imagine how that actually works. Are there any other mysteries out there that scientists are working on?
Yeah, another big area is magnetism at extreme scales.
Extreme scales.
Like what happens to magnetic fields in a black hole.
Oh, wow.
Or in the super cold temperatures of deep space.
Yeah.
These are questions that really push the limits of what we know. And they need new tools and techniques to answer them.
So even with all our advancements, there's still a lot of wonder and mystery around magnetism.
Definitely. Every new discovery just leads to more questions, That's what makes it so fascinating. As we get better supercomputers and quantum sensors, who knows what we'll find out next?
I have to say, this has been an incredible journey. We've gone from ancient lodestones to the quantum realm, thousands of years of history. And it's clear that magnetism is a force that continues to shape how we see the universe. And it drives innovation in so many ways.
It really speaks to the power of human curiosity, that desire to understand the world around us.
It really
And the
does.
best part is, this journey isn't over. There's still so much more to learn.
So, to everyone listening, the next time you see a magnet, think about the amazing story behind it. Generations of curious people, from the ancient Greeks to quantum physicists, they've all been drawn to this force. And who knows what incredible discoveries are still out there.
There's a whole universe of magnetic stuff waiting to be explored. Keep asking questions, keep exploring, and never lose that sense of wonder.
Until next time, keep diving deep.